everyone! Alright, today we have something a little special. So last week I talked to you guys about poetry. That's some English stuff. This week I decided to switch it up with some science. Yeah. So we're going to do one of my favorite experiments as a child in science class. But first we need a little background information. So, if you haven't noticed, the everyday materials, everything around us, from wood, water, metal, plastic, all kinds of stuff, literally everything. Everything around us generally fits into three groups, three categories: solid, liquid, and gas. Now I'm sure some of you have already heard what a solid, liquid, and gas is, and you know what that is. And you're like, Teacher Adam, come on, boring. But some of you don't. It's okay. A solid is something that's hard, like the board there. A liquid is something that moves and fills the shape of its container, like this water or soda. That's a liquid. And a gas, like the air we breathe. Can't see it, can't really feel it, but you know it's there. Yeah, that's a gas. Now, these three categories represent the different possible states of matter. What is that? So, well, matter is, like I just said, everything around us. Everything is made of matter. We're made up of tiny little particles that build and build and build to make cool stuff, like people, or dogs, or tables, or chairs. It's just different states of matter. Now, a table is a solid, while water is a liquid. And there we breathe as gas, like I said. But certain things, like water specifically, they can change their states of matter. So water normally is just water, a liquid. But let me ask you this. What if you stick your water in the fridge or the freezer and it gets really cold? Then it gets hard and it turns to ice. Well, it just changed from a liquid to a solid. Now let's go the other way. Let's say you are cooking rice, or cooking rice is a good one. And you see that it looks like smoke coming out of the top of the rice cooker or the pot. That is steam. When water gets really hot, it turns into a gas. So it changes its state of matter. So some materials, like I just said, can transition in their states. Water can exist as a solid. Ice can exist as a liquid, water, and a gas, steam, or vapor. Now, in this lesson, we are going to explore the properties of something I like to call Oobleck. Oobleck. So, Oobleck is a simple mixture of corn flour. I have cornstarch also works, but I could only find corn flour. All right, so I have corn flour and water. That's all we need. Now, some like to use a little baking soda just to make it not as sticky, but that's okay. We'll talk about that later. Yeah, so Oobleck is just a simple mixture of flour and water. Now, what's so special about it? Why am I making a video about it? First off, it's fun to play with, so there's that. Secondly, Oobleck is unique because it can behave as a solid and a liquid. What you talking about, Teacher Adam? How can something act like a solid and a liquid at the same time? Well, many centuries ago, long time ago, a scientist and a mathematician named Sir Isaac Newton. Yeah, Sir Isaac Newton proposed that liquids flow at a constant and predictable rate. Like if I were to pour out my water bottle now, I'm not because I'll make a mess. If I pour out the water, it will pour out at the same rate. Like it will behave the same. You know, no matter how hard I go and I move in the water, you know it's going to move around you the same. Like when you're in a swimming pool and you're walking in the water, it's kind of hard to move, right? Yeah, the water is moving around you. But it's the same if you're walking and if you're trying to run. If you're going slow and if you're trying to go fast, it's the same. It behaves the same. Not with Oobleck, though. Oobleck is very special. Now, water is a normal Newtonian fluid. That's what we call it, a Newtonian fluid. A liquid that follows Newton's law of physics, saying that no matter how hard or soft you try to move through it, it flows the same. However, as we will soon find out, Oobleck does not have a typical flow. It is not a Newtonian fluid. It is what we call a non-Newtonian fluid. Unlike water and others, non-Newtonian fluids respond differently, depending on how quick, how fast you try to move it around, or what's known as the strain rate. Now, we will learn not only how to make our own Oobleck, but we will be making observations and performing tests or experiments on our Oobleck, just like real scientists. Alrighty. Now, for our experiment. First things first, as you noted, I got my area ready. As you've noticed, I changed the camera around and I got my stuff ready. Now, this can get messy, alright? So, I would warn your parents before doing it. Also, we need to go over what we need. Okay, first of all, we need an area that we can clean easily. Step number 1. So I have my table, I have it cleared off. I can just wipe it down when I'm done. Now, what do we need? Well, we need something, I don't want to use that one. I want to use my circle. So, we need a container, something to hold our creation. Like I said, we need corn flour or cornstarch. You can find this at most any grocery store or supermarket. And water. Now, 2 optional things. You don't need it to make it, and I'll show you because I'll just make it like this first. But to make it a little different, you can either add baking soda, which should be right next to your flour in the supermarket, and food coloring. Yeah, I got some food colors to make it different colors later on. Now, it's pretty simple how we make Oobleck. We get our ingredients, we have our clean space, we have our container. Now, we need to add our ingredients together. Real easy, just pour in some cornstarch. All right, now, as you can see, I have my cornstarch in here. All right. Now, the secret here is adding 2 parts cornstarch, 1 part water. All right, you don't want too much water. I'll show you. Now, you pour a little bit in there, just to cover it a little. All right, just to cover it a little. All right, now start spinning and get in there. You need to mix it up. And if you go ahead and feel it, yeah, that's not enough. That's too much water. You see, now I got it all mixed up. Yeah, it's just water. It's just water. All right, so if that happens, clearly I put in too much water. Wanted to show you this first. If you put in too much water, what do? Put in more cornstarch. It is that easy. It's pretty easy to make what we're making today. So I need to add some more cornstarch. Now I might have added too much. All right, now the trick here is finding your ratio. How much water to cornstarch? Now, alrighty. Oh, now it's starting to, yeah, still too much water. But it's starting to feel it. I feel it. It's getting milky. It's getting slimy a little. All right? Now, this is when I would use baking soda. It helps it bind better. It helps it bind so it doesn't melt in the water as much. All right, just a little. Just a little. Alrighty. Now, I should be able just to pour a whole bunch more. Ooh. And hopefully not spill it anywhere. All right. There we go. There we go. Yeah, there we go. Now I think I might have too much of this. And as you can start to see, it's acting all weird, right? Yeah. Now, I need to mix it up some. Still. So as you see, it still looks like a liquid. Still looks like a liquid. But if I can pick it up, oh, no, still need to mix it more. All right. Now, yeah, still too much water. Still too much water. I need, I think, the way it feels, a bit more baking soda, just a smidge. So if you want, there are some guides online to help you with your ratios if you have measuring cups, but I didn't have any measuring cups, so I'm just going by ear. That means I'm trying to find my ratio myself. All right, I can feel it thick. Yeah, slimy. I made some slime right now, but it's not quite where we need it to be. It's still too much water. So what do I do but add more cornstarch? All right. So, now, a non-Newtonian fluid, like Oobleck here, there we go. Now you see it's getting all crumbly. Yeah. See? How I can pick it up, but then I let go and it just starts to melt away, kind of like water. But it's still, I can pick it up like a solid, like that. See, I can squeeze it, but then turns into water. Crazy, right? So this is a non-Newtonian fluid. Now, a non-Newtonian fluid is just a big way to say something that acts like water, acts like a liquid and a solid at the same time. Now, like I said, if you move through it slowly, softly, I can just stick, yeah. If I go slowly and soft, I just go right in, no problem. I can feel it moving around my fingers just like I would in water. But let's see if I try and go fast. See, if I go slow, I come right out. Come right out. You see? But let's see, go back down slow. Let's see what happens when I try and pull out fast. All right, you ready? Whew, I can't. See, I can squeeze it and play with it like that, and it's like a solid. As I'm putting force, as I'm putting pressure, the harder I squeeze, the harder it feels. But when I don't squeeze, it's just like water. Yeah, you can squeeze, 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 and it changes. See, this is what's so cool about non-Newtonian fluids. It changes between liquid and solid depending on the force applied, which is a fancy way of saying, yeah, so a non-Newtonian fluid changes between a solid and a liquid depending on the force applied, which is a fancy way of saying it's as hard as you push it. So right now, I can make it powdery almost. See, I can push it and crumple it up. You can't really see, my hand is in the way. But I can play with it like that, like it's chalk, like it's a piece of bread. But then I just let it sit and it's back to liquid, no matter how hard it takes. It always will go back to liquid as soon as you don't put any pressure on it. All right? Now, let me ask you something. What will happen if I put, I'm stuck. Now, what will happen if I try to punch it? What do you think? Now, let's see. Is it going to cause a lot of force? Am I going to put a lot of force behind it? Now, make a fist. Ooh, this feels so weird. I'm going to punch it. What do you think will happen? Well, if I punch water, what happens? Your hand goes right through the water and it splashes everywhere. Let's see what happens when I try and punch this. All right, so, nothing. Nothing, I just got stuck right at the top. It didn't even let me punch it through. Let's try it again. Nothing. I must be weak or something. I know it, it's not it. Nothing. It won't let me in. I'm putting too much force, so it's acting like a solid, like something hard. All right, let's try it slowly. Let's just go right in. Just go in. See? It lets me in. It behaves like water because I added low force. If you put a low amount of force into Oobleck, it acts like water. So if I come out slow and soft, it lets me out. Come on. Come on. Come on. All right, apparently I'm not slow and soft enough. There we go. There we go. All right. But if I try and go in hard, it won't let me. Same as if I go in soft and try and pull it out really fast. Oh, ow, that hurt. Yeah, I take some with me. All right. So this is Oobleck. See how I can pinch it together and it gets hard and soft almost, like it's dry. But then I let it go and it's watery again. Show you again. Try and pick it up. If I do it slowly. All right. Pick it up. Come on now. Come on. Try and make a ball, like a ball of sand. So see, I can break it up. I can push it. I can make it crumbly. But then the second I let it go and I stop applying force, it behaves as a liquid. So this is what's so cool about non-Newtonian fluids. All right? Now, what's so special about this stuff? What's so special about this stuff? Well, non-Newtonian fluids are more common than you think. Now, what about the most used non-Newtonian fluid? The most used non-Newtonian fluid, you see it all the time when people are building. It's called concrete. All right? Now, concrete has a very special chemical in it that after it dries and becomes a solid, it becomes a normal solid. Something that will happen here once all the water goes away. All right? But right now, it's still fun to play with. All right? See, I can make it all chalky. But then, water. Now, we use non-Newtonian fluids more than you think. Like I said, we use it for concrete. We have engineers who use it to help protect sensitive parts in space shuttles and airplanes. We have it in our cells. In our cells, you know, the things that build up our body. Yeah, we have them in our cells. Yeah, it's what keeps our cells safe in their shape. Otherwise, they would just be like water and everywhere. Now, I want you to try and make this on your own. All right? Try and make it on your own. See what you can do with it. All right? Think of your own questions and test them out. What do you think will happen if you add more water? What do you think will happen if you add more cornstarch? All right? Test your answers, or test your questions. All right, make your own oobleck. All right, now, I got some pretty hard stuff. I'm constantly adding force, but I wanted to do something cool. Like I said, I already showed you how I use the baking soda. It helps it make it faster. Downside is it helps dry it out faster, so it doesn't last as long. So if you want to keep it, just use cornstarch and water, but that takes longer to make and get it ready. But of course, I have food coloring. Now, what if I add some colors? What do you think will happen? Well, I like purple, so that means I add red and blue. 3 drops of red, 2 drops of blue. And then we mix it up, right? Oh, this is so weird. This is so weird. All right. I'm just picking up blocks and putting them back down. All right. Now, it is getting a little dry for me, so I want to add a small amount of water. This is the baking soda problem I mentioned. It helps dry it out even faster. But if I add just a little, just to help mix in my colors. Yeah, get in there. Get in there. There we go. So the harder you push, the harder it gets, which is the basis of non-Newtonian fluids. Now, you've probably used one already in, I don't know, it depends. Do you like to use ketchup or mayonnaise or any other sauce really? Most sauces are actually non-Newtonian. All right, so if you start shaking up a bottle of ketchup, what happens? It behaves differently. Now, it behaves differently than Oobleck because Oobleck is special. Oobleck, the harder you put a force on, the harder it gets. The opposite is said for most non-Newtonian fluids, like sauces. So like if you have a bottle of ketchup in your fridge, and it's really thick, and it's slow, and it won't come out the bottle, what do? You shake it. You shake your bottle. That applies force to it, and it changes it into a more liquid state. It's backwards from what Oobleck does. As you can see, the more force you add, the harder it gets. That's why I said clean your space. You might get stuff everywhere. But if you stop acting, it behaves like water. Alrighty. Now, I want you guys to show pictures, videos, anything, showing your making process of making Oobleck and your experiments. I want you to think of a question. What question do you have? Then test it. Like, what happens if you add more water? What happens if you add more baking soda? What happens if you leave it out in the sun? Ooh, that's a good test. What happens if you put it in the freezer? Ooh, I don't know. You should test it and find out. All right, so that is your assignment. I want you guys to test making your Oobleck. All right? Okay. Now, that's all for me, I guess. I got a huge mess to clean up. I'll see you next time, guys. Bye.